Hey guys, before we get into evaluating limits, let's look at how we use the unit circle, since we'll be using that on evaluating limits of trigonometric functions. So here we have the whole unit circle. Now, as a reminder, the coordinates represent the x and the y. X is the cosine value at the angle that's given, and the y value is the sine of the angle. Now in calculus, we're not going to use degrees, so we can basically ignore all of these degree measures. We're only going to use the radian measures, which are the ones that have pi. So even though the unit circle only gives us cosine and sine values, we can find any of the trigonometric functions from the unit circle by applying these properties here. Tangent is equal to the sine divided by cosine. So since we have the coordinates, in order to find tangent, we would divide the y over the x, since y is sine and x is cosine. Secant is the reciprocal of cosine. So whatever the cosine value is, just flip it. Same thing goes for cosecant. Cosecant is the reciprocal of sine. So whatever the sine value is, you flip it. And cotangent is the reciprocal of tangent, so instead of dividing sine by cosine, we flip that and we divide cosine by sine. So let's practice using the unit circle. First off here, we have the cosine of 2 pi over 3. Cosine, remember, is the x value. So I look for 2 pi over 3, which is here, and the x value is negative 1/2. So that is the cosine value of 2 pi over 3. Now just before I continue, just a couple of things to take note of. In quadrant 1, we have the a. That means that all of our trigonometric functions will be positive. Additionally, all of these radians are always just pi over and then whatever the denominator is, which all the denominators are basically the same, 3, 4, and 6. In quadrant 2, we have s. This means that only sine and its reciprocal, which is cosecant, are the only trig functions that will be positive. And the radian measures here, the numerator is always one number less than the denominator. So that's why we have 2 pi over 3, 3 pi over 4, etc. In quadrant 3, we have t. For t, that means that only tangent and its reciprocal, cotangent, will be the only functions that are positive. And here for the radians, the numerator is always one larger than the denominator. In quadrant 4, for c, that means cosine and its reciprocal secant will be the only trig functions that will be positive. And if we look at the radian measures, the numerator is double the denominator minus 1. So for example, for 5 pi over 3, if you double the 3, we get 6 minus 1 is 5. 4 times 2 is 8, minus 1, 7. 6 times 2 is 12, minus 1, 11. So that's how you can find your angles easier if you can remember those patterns for the numerator and denominator. Additionally, we have these quadrantal angles. Quadrantal meaning that it lies on an axis. A full revolution is 2 pi. And there are 4 divisions. So if you divide it by 4, we get pi over 2. That means that at every 90 degrees, which is equivalent to pi over 2. So we can see here the pi over 2. If I add another pi over 2, we get 2 pi over 2, which is pi. If I add another pi over 2, we get 3 pi over 2. And if you add another pi over 2, we get 4 pi over 2, which is 2 pi, and we end up back at where we started, which is at 0. So now let's continue with these examples. The sine of 7 pi over 6. Instead of like scanning my whole unit circle, and it can take a couple seconds, an easier way is I know that 7 is 1 more than 6, so this angle must be in quadrant 3. The sine is the y value, which is negative 1/2. Moving on to tangent of 4 pi over 3. 4 is 1 more than 3, so that must be in quadrant 3. Tangent is when we divide the sine of 4 pi over 3 by the cosine of 4 pi over 3. which is the y divided by the x. So we have the negative square root of 3 over 2 divided by the cosine, which is negative 1/2. Since we have a fraction divided by another fraction, we're going to copy, change to multiplication, and flip. So negative square root of 3 over 2, change to multiplication, and flip the second fraction, which is negative 2 over 1. Now we can multiply straight across and then simplify. But what I like to do is I like to look at the diagonals, because diagonals mean that it's divided. So we have this 2 and this 2, which will cancel. And then we multiply. Negative square root of 3 times this will now be a 1 and a 1, because I can divide each by 2. Negative square root of 3 times negative 1 is positive square root of 3 over 1 times 1, which is 1. So this would be my answer, square root of 3. Now for the secant of 7 pi over 4. 7 is double of 4 minus 1, so this is in quadrant 4. Secant is the reciprocal of cosine. So I'm going to take my square root of 2 over 2, and I'm going to flip it, which is 2 over the square root of 2. Now remember, we can't have a square root in the denominator, so we're going to rationalize. We're going to multiply both the numerator and the denominator by that square root, which would give us 2 square root of 2. And because we have 2 square roots multiplied, remember that if the numbers inside are identical, that just cancels out the square root, and we end up with 2. Or if you think about it, the square root of 2 times the square root of 2 is the square root of 4, because I can multiply those 2's together, and the square root of 4 is 2. These 2's here will cancel, and I'm left with my final answer of the square root of 2. Now let's do the cosecant of pi over 6. Since the numerator is just pi, this is in quadrant 1. Cosecant is the reciprocal of sine. So I'm going to take my sine and I'm going to flip it. 1/2, when you flip it, you get 2 over 1, which is just 2. Finally, the cotangent of pi. Cotangent of pi is the cosine of pi divided by the sine of pi. Pi is a quadrantal angle, which is over here. Here is my cosine and my sine. So I'm going to divide negative 1 over 0. Now we can't ever have 0 in the denominator. Therefore, this value is undefined. And that's how you use the unit circle.